Ladies and gentlemen, 114, defining rotations. Here we go. For each figure, which pair of angles appears congruent? And how could you check? Well, let's see. These are all acute. When we talk about angles being congruent, you could think about, right, this, let's see here. This right here is a 90-degree angle, right? Right? Isn't that also the same as like the corner of the screen, right? Now, this edge at the corner, top edge of the screen and the side of the screen, whoops, are definitely longer than these edges here on this, right? But they're still congruent as angles. Now, if we look at these, which ones look like they're congruent? Well, this one and that one might be congruent, right? And we could check by what? Doing what? Same thing we did last time, right? See if they match. Move B over to H and then rotate it up until C touches L. And if A lands on G, boom, there you go. They're congruent, right? These are obviously not congruent, and these are obviously not congruent. This is way too skinny of an angle to match either one of those. All right, let's look at these. Which ones are congruent? Well, let's see. This one is acute. This one is obtuse, more open than a 90-degree angle. And this one is also more open than a 90-degree angle. O, open, obtuse, right? So these two would be the ones that I would say would be congruent. So that would be angle LSR and angle KBP, right? And up here, we're naming these angles in the same order that we would draw them if we weren't allowed to pick up our pencil, right? So it'd be like A, B, C, or you could say C, B, A. But you can't say B, C, A because you can't draw it that way, right? Same thing over here, L, H, G, or G, H, L. But you can't do H, G, L because that line segment is not there, right? Okay, how about this one? Well, looking at these, I would say that these two look like they are about the same, right? So that would be DVG, and if I spun that around, that would be LJX, right? Or you could do XJL and GVD. All right. This one looks a little more complicated, but it's not really. Is this angle acute or obtuse? That one's acute. All right. Acute or obtuse? Obtuse, right? Acute or obtuse? Acute. Okay. So obviously, these two angles would be the ones that are the same. And we could check that again by moving H over to E and then rotating things until they lined up with each other. Now, if you wanted to name this angle here, you could say LHG, you could say LHR, you could say LHK, right? You could say QHR or QHK or QHG, and that would all be the same angle. And over here, TEU, oh gosh, there's so many options, right? As long as you're naming one of the points on this line segment, then the letter E, and then one of the points on this line segment. Okay, we are skipping task 5, skipping task 6, and skipping task 7. We are looking at 8. Okay. It says draw a segment, label endpoints A and B. Okay, I can do that. Line segment. I'm just going to go boop and boop, right? And I'm going to, I guess we're going to, doesn't have anything else. So I guess I'm labeling them A and B. So here is A, right? And We'll label the other side B. All right, great. So what was the next step? Rotate segment AB clockwise around center B by 90 degrees. Okay, clockwise goes this way. All right. Looks like I'm gonna have to adjust where I put this thing, or move the graphics view down. Here we go. Okay, so it says to move it clockwise around center B by 90 degrees. Okay, so that's this tool right here, rotate around point. I'm selecting this object here. I'm selecting point B as my center, and it says 90 degrees, and which way? Clockwise. Clockwise. All right, boom. Ta-da! Now label the new endpoint. Well, what would it be? If A moved up here, it would be A prime. So here we go. All right. Bam. Okay, and we're gonna just get this out of the way so we can just use our A prime. There we go. Okay. There we go. And then it says use the polygon tool to draw triangle ABA prime. Okay. Seems pretty straightforward. Polygon tool, A, B, A prime. And of course, if I don't close it off, it's not going to be a triangle. I got to click back on A, and that'll close it off. Okay, cool. What other properties do we notice in the figure? Explain your reasoning. Oh, wait, it says what kind of triangle did we draw? Well, since we made a 90-degree angle, this is an example of a right triangle, right? Because it has a right angle in it, right? What else? What other properties do we notice about the figure? Well, we know it's a right angle because we rotated 90 degrees. What else do we know about this triangle? Well, since we rotated this line segment, we didn't stretch it at all. So it has to be the same length. So that means that this side here and this side here have to be the same length. And if we look, this is 1, 2, 3 squares, and this is 1, 2, 3 squares long. So it would also be that two sides are equal. That would make it an isosceles triangle. Isosceles. Right? It's an isosceles triangle. Triangle. Oops, wait, here. It's an isosceles triangle because AB is the same length. Or I should have done same length as it should be A prime, B prime, A prime, B prime, because that's the second one, right? This one has to be the same length as that one. I guess I don't have to put B prime in there. A prime B is the same length as AB. There you go. Great. All right, now use the applet below. It says to rotate segment. Okay, so draw a segment, label endpoints C and D. All right. Much like we did last time. Here we go. Here's a segment. There, and we'll make this one 4. Why not? Mix things up a little bit. Okay, so this is point C. And this is going to be point D. There we go. All right, cool. Then it says rotate segment CD counterclockwise around center D by 30 degrees. Okay, so that's this tool here. Rotate around point. Rotate this line segment CD around this point, and it said 30 degrees, and I think it said counterclockwise. Boom. Okay, so now that's that. All right, cool. And then label that new endpoint. Well, what should this be called? If I moved this down here, this should now be C prime, right? Yeah, C prime, because that's the image of this original one. All right, then it says to do what? rotate segment C prime D counterclockwise around center D by 30 degrees. Okay, seems like we've done this before, but this time we're using this one to do our rotation. All right, so rotate around point, select the object, choose our center of rotation, which is point D, and again we're going to do 30 degrees, and we're doing counterclockwise again. Boom, there we go. And it says label the end C double prime, right? Because C single prime was here, and C double prime is going to be down here. C double prime. There we go. All right. There you go. Cool. Then, what does it say? It says, use the polygon tool to draw triangle CD, C double prime. Okay. Polygon tool, C, D, C double prime, and then back this way. Okay. All right. And then what does it say? What kind of triangle did we draw? Well, what can we say about this triangle? It's an acute triangle, right? It doesn't have any angles that are obtuse. How big is this angle? I wonder. Well, we know that it is 30 degrees in this gap right here. I'll use the pen, right? This little section here is 30 degrees, and this section here is also 30 degrees. So that means that combined together, right, that has to be 60 degrees. So if I look at this angle here, that's 30 degrees. You can barely see it, right? And then the same thing here. This is going to be another 30 degrees, right? There's another 30. But if I look at this whole thing, and this is going to be just a jumble of numbers all over each other, you'll see that that's 60 degrees. So let me go back and get rid of these guys. And if I measure out this angle here, that ends up being 60 degrees, which you can't read because of the way things got moved around. Maybe if I can move some of this stuff around, it'll help. Nope, it's still going to be jammed in there. Well, oh well, back we go. All right, so that's definitely 60 degrees. Now, we also know that it's what kind of triangle? That's right, it has to be isosceles because this edge and this edge have to be identical, right? This edge of the triangle and this edge of the triangle have to be identical. CD is the same length as C double prime D. So it's also isosceles. We know that an isosceles triangle has two equal sides. Let me make sure that I'm not zoomed out. All right, there we go. Right? So it has two equal sides. 1, 2, right? And we also know that the angles across from those sides are also equal. So the angle that's across from this side, this angle right here, and the angle that's across from this side, this angle right here, are the same. Okay? So we know that this is 60 degrees because 30 plus 30 is 60. So if I look at this, I'm like, okay, I have some angle here, which is, we'll just call this, angle X. And this might be angle Y, but we know it's identical. So what we have is we have three angles. We have an X, we have another X, and we have a 60. Now, if you guys remember from the last time you took geometry, back in middle school probably, that if you add all the angles of a triangle up, you end up with 180 degrees. So that means that, let me just do this with text here. That means that 180, right, has to equal 60 degrees plus our angle x plus our other angle x, right? So that means that 180 has to be equal to two of those x's. 2x plus 60. Right? 2x plus 60. There's 1x, 2x's plus 60, right? And we know how to solve this, right? What do you do here? Excuse me. First step is let's get rid of this 60 because we don't need it. So we're going to subtract 60 from both sides. All right? So let's see. Will it let me do this? Nope. All right. So I'm going to cancel that. All right, I guess I'm going to use the pen tool. All right, so I'm going to subtract 60 from here. And I'm going to subtract 60 from the other side of the equation because that's just the way that we do things. We keep things fair, right? If two things are equal, we have to do the same thing to them in order to keep them equal. So then this means that 180, now I'm going to flash back here and go down here. So that 180 minus 60 is 120. And that has to be equal to 2 times x, right? Right? Once you subtract the 60 off of there, you get 120. Once you subtract the 60 off of there, you're just left with the 2x. So what do I do here? That's right. I'm going to divide both sides. I'm going to divide this by 2 so that I have just one x left. I'm going to divide this by 2. And I'm going to divide that by 2 also, right? Because I have to do the same thing to both sides. And I'm going to end up with, well, what's 120? On this side, I'm definitely going to end up with x. What's 120 divided by 2? What's 12 divided by 2? Well, that's going to be 60 equals x. Ta-da! All right, cool. So there we go. Hey, wait a minute. If this is 60 degrees and this is 60 degrees, that's also 60 degrees. So that means it's equiangular, right? Equiangular. All angles are equal. We also know something else. Wait a minute. If this angle is 60 degrees and this angle is 60 degrees, then that means that these two angles are the same, which means that the sides across from those angles are also the same. This side is across from this angle, and this side over here is across from this angle. That means that this side is also the same length. So we have not only a triangle that is equiangular, we also have a triangle that is equilateral, right? This is equal angles. Oops, angles, not angels. Equal angles. And this one is equal sides. Right, this is all equal angles. And all equal sides. So if both of those things are true, what we call it is regular. I know that's weird because it seems like something that's regular would be totally ordinary. But in this case, regular means that everything is the same about it. In other words, the angles are all the same. The sides are all the same, right? All right, cool. There you go. That's what kind of triangle that is. Okay, so there, that was task 13. Right? You constructed an equilateral triangle by rotating a given segment around one of its endpoints by a specific angle measure. An equilateral triangle is an example of a regular polygon. We just talked about all of that, right? A polygon with all sides congruent and all interior angles congruent. Try to construct some other regular polygons with this method. Okay, so we're going to take a line segment and we're just going to make it 2 pieces long, right? 2 squares long. And we already did the thing where we rotated it, we rotated this object around this point, and we do that by 60 degrees, right? And we go counterclockwise, boom, and then we have our polygon, right? And that's a regular triangle. How could we do a hexagon? Well, this is an all-star question, guys. This is an all-star question. Well, what other regular polygons do we know, right? Where they have all the same sides and all the angles are the same. Well, obviously a square, right? So let's see here. If I start off here and I have this, how far would I have to rotate this in order to set myself up for a square? Well, oops, didn't mean to do that. Cancel. Go back 1, 2, there we go. All right, select this object, right? Select this corner. I would have to go 90 degrees because that's a right angle, right? And then I could do the same thing here and rotate it around this point. And I'm still going counterclockwise, 90 degrees. And again, the next side, rotate it around this point. And I've got 90 degrees. And I got a square. Great. Awesome. Right? So the question is, how about, let's think about the angles here for a second. We know that this is 60 degrees. This is 90 degrees. So if I want to make one that's 6 sides, how far would I have to go? Well, do we have any examples earlier on that we could use? No. Maybe in the other lessons we did. Remember that triangular grid we had? Right? Everything was multiples of 60 degrees, right? Let me get rid of this triangle here. Boom. Okay. So if I rotate this segment here, I'm going to use this. Again, I'm going to rotate it 60 degrees counterclockwise. Boom. And that'll get me back to my original point. So this was all 60 degrees. What if I take this, rotate it around here, 60 degrees counterclockwise. Ooh, this is starting to make me think that I could make a hexagon here. Well, how many triangles is this angle right here? Can you guys see the hexagon that would be made? It would be like sort of shaped like this. If I did the same thing here, rotate it around this point, change it to 60 degrees, counterclockwise. Oops. Wait, what did I do? Oh, whoops. I know. I needed to do it clockwise. This one, around this point, 60 degrees, clockwise. There you go. Right? Look at that. How many degrees is this? Could I do it over here? Let's get rid of this. Let's get rid of these. Make a hexagon. Well, it was 2 triangles, so that would be 120 degrees, right? So let's try it. That's looking promising. Now, if it's a regular polygon, it needs to have the same angles all the way around, right? This was 60, then 60, then 60. This was 90, then 90, then 90, then 90, right? So this has got to be 120 and then another 120. So here we go. Let's try this, right? We're rotating around this point, 120. And we're going to rotate around this point, 120. And around this point, 120. And around this point, 120. Boom. All right, cool. So hang on a second. This was 60 degrees and has 3 sides. This was 6 sides, but it was 120 degrees. What would I do if I wanted to make an octagon? An octagon has 8 sides. This has 4 and was 90 degrees. That's a puzzle I'm going to leave up to you. See if you can figure it out. I'll give you a hint, though, before I go. Think about this angle right here and this angle right here and this angle right here. This is 60, this is 120. This is 120, this is 60. This is 90 and this is 90. But I want to make an octagon. An octagon has 8 sides. If I want to think about where, like, right, if I make an octagon, it's like it has to turn. Oops, I went the wrong way. Let's try that again. All right. So imagine that you're walking along, and in order to turn, to walk around, right? If you were walking this direction, then walking this direction, if you're looking at a map, right? You're walking down the street, and then you turn, and then you turn again, right? But you're not turning it. Maybe you're standing in the middle of a football field, right? If you turn 120 degrees, and then you turn again another 120 degrees, and then you turn again 120 degrees, you'll end up facing the direction that you originally started. So 3 times 120 is equal to 360, which is a full circle. Here, you're turning only 60 degrees, and you do that a bunch of times, right? So, I don't know if I can do this quite right, but I will try. Right? Here would be another 60-degree turn, another 60-degree turn, another 60 degrees, right? And so the issue is that as you turn, eventually you're going to end up back in the same spot, right? How many times you have to turn, this is a smaller amount of turn because it has more sides. How many times do you turn? 6 times. 6 times 60 equals 360. If you have an 8-sided shape, how much are you going to have to turn? There you go. That's the puzzle. That's as much of a hint as I can give you. Make an octagon. a regular octagon.